This is the second video talking about stoichiometry. In the first video, we said that stoichiometry is the relationship between the relative quantities of substances taking part in a reaction. And so we're going to use the law of conservation of matter that says that matter is neither created nor destroyed in a chemical reaction, and the atoms aren't going to change identities. They can rearrange to make new molecules. And so the mass of our reactants has to equal the mass of our products. So let's look at this example. Let's take iron, react it with molecular oxygen to make Fe2O3, iron 3 oxide. So what those coefficients tell us is that 4 moles of iron reacts with 3 moles of molecular oxygen, O2, to make 2 moles of Fe2O3, iron 3 oxide. So let's just say we've got 25 grams of iron. How many grams of Fe2O3 can be produced if we have sufficient amount of oxygen to make things exactly react? So we need to go from grams of iron to moles of iron to moles of Fe2O3 to grams Fe2O3. We don't know a gram to gram ratio of iron to iron 3 oxide. We can do moles. We can't measure moles directly in the lab. We can only measure grams. But to do the ultimate conversion, we got to get everything to moles. So when we're doing these stoichiometry problems, when you see grams, just go ahead and think you're going to have to change to moles. So to change from grams to moles, we're going to use the molar mass. Go from grams iron to moles iron. Go from moles iron to moles iron 3 oxide, we're going to use our stoichiometric ratio, or our bridge factor. Then you go from moles of Fe2O3 to grams Fe2O3, we're going to use the molar mass of that compound. So 25.0 grams of iron. We're going to change that to moles iron. And 1 mole of iron is 55.85 grams of iron. We got that from the periodic table. So grams iron cancels. And now we will convert from moles iron to moles Fe2O3. Now to do that, we need our stoichiometric ratio. That says that 2 moles of Fe2O3 are produced for every 4 moles of iron that's reacted. And then we can convert to grams Fe2O3 by using the periodic table and calculate the molar mass of Fe2O3. And that happens to be 159.69 grams of Fe2O3. So grams Fe divided by grams Fe, moles Fe divided by moles Fe, moles Fe2O3 divided by moles Fe2O3, and that would give me grams of Fe2O3. So 25 divided by 55.8 times 2 divided by 4 times 159.69 would give me 35.74 grams of Fe2O3, or 35.7 grams when I get my significant figures right of Fe2O3. So that's how we calculate theoretical yield. A second part to this problem could have been how many grams of oxygen were actually consumed. How many grams O2 consumed or were reacted? There are two ways to go about doing this. A very quick way is to remember the law of conservation of matter that says that the grams reacted has to equal the grams produced. And so I've got 35.7 grams of product, and I had 25 grams of iron. I can tell how many grams of oxygen were consumed. It should be 10.7 grams. Well, let's check that. Let's check that by doing the same method that we did up before. Let's take grams of iron, change that to moles of iron, change that to moles of molecular oxygen, and change that to grams of molecular oxygen. So 25.0 grams of iron times 1 mole of iron is the same as 55.85 grams of iron. Grams of iron divided by grams of iron cancels. I've got moles of iron. I want to cancel that. I want to convert that to moles of oxygen. So moles of oxygen is going to go in my numerator, moles of iron in the denominator, so that would cancel. But I needed my stoichiometric ratio that says, and go back to my balanced chemical equation up top that says that 3 moles of oxygen reacts with 4 moles of iron exactly. And then I can convert moles of molecular oxygen, moles O2, to grams O2 by using my periodic table. So 1 atom of oxygen is 16, 2 would be 32. I'm talking about moles, so I really need to change that to grams. So moles O2 divided by moles O2, that'll give me grams O2. So 25 divided by 55.85 times 3 divided by 4 times 32. And that gives me 10.7. Yay! And so that's how we did this problem of the combination of iron and oxygen to make Fe2O3.